Hello everyone, welcome back to my channel. Hi Mathematics. Today we have very interesting questions. 3 to the a plus 3 to the a equal to 60. We need to solve this question for a. So if you have your thoughts, your answer, you can write it in the comments below and then we will check our answer. So it will be really interesting. So first of all, on the left side, I want to add it. So 3 to the a plus 3 to the a equal to 2 times 3 to the power a. And a lot of students might be asking why we can add it in that way. Here's my quick explanation. 3 to the power a, for example, this is our t, and we add to this t, we add the same 3 to the power a, so we add the same t. T plus t equal to 2t. So that's why we have this coefficient 2 in front of it. So I hope you understand it. Secondly, let's divide both sides by 2. So let's divide both sides by 2 because we need to find our a. And step by step, we're getting closer and closer to our a. So we have 3 to the a equal to 60 over 3 equal over 2 equal to 30. And here's our equation. Of course, there are a lot of ways how can we solve it, but the best way is to apply log on both sides. So let's do it right now. We're going to apply log on both sides. On the left side, so we have log 3 to the power a, and we're going to apply it on the right side, log. We have right here log 30. Right now, there's like a really, maybe the most popular rule when we're talking about log. When you have log, right here we have base of e, maybe right here we have b, and right here c. This c we can easily write in front of this log. That's why log is extremely great in terms of properties, in terms of like simplification. We can write it as c log b to the base of a. Okay, so I hope you understand it. This is great thing. So right now this a, we can write it right here in front of it. Let's do it. So we have a log 3 equal to log 30. And the final move, let's divide both sides by this log 3. Yeah, because we need to find only our a. So let's divide both sides by this log 3. As a result, we have a equal to log 30 over log 3. And a lot of students might be thinking that, yeah, this is our final answer. We solved this question absolutely correct. And you know, I agree with it. This is a correct answer, but we can simplify this a little bit. This log 30 right here at this place, so in the middle right here, we can write as 3 times 10. Okay, let's do it. So we have log, we can write it as 10 times 3. We can write it in that way, obviously. Yeah? And all over, we're going to divide it by log 3. Okay, really great. And right now, that's why I do this, because there's like really important property. So whenever you have a log of a product, you can write it as a sum of 2 logs. It works perfectly with the multiplication and division. So this log of a product, I can write as log 10 plus log 3 and we're gonna divide it by log 3. We can divide it like that. So I really hope you understand it. What we're gonna do next? Secondly, what we're gonna do, we're gonna divide this log 3, we're gonna divide this numerator by this log 3, but not the whole numerator as like that. We're gonna divide it by parts. So log 10 over log 3 and log 3 over log 3. Let's do it. So we have log 10 over log 3 plus log 3 over log 3. Okay, really great. And right now, this log 3 over log 3 equal to 1. So as a result, we can start with 1 plus this one, log 10 over log 10 over log 3. And of course, this is up to you. For me, this is like a final answer, but this is up to you. You can easily split this log 10 by log 5 plus log 2, okay? And you will have three expressions. So 1 plus log 2 over log 3 plus log 5 over log 3, but I want to leave it like that. Right now, let's check this root real quick. So here's our final answer to this question. Yeah, and right now, let's check it real quick. Let's check this root. Let's do it. So let's check this root. First of all, I forget a little bit about this one. I'm going to show you how can we, I'm going to say a approximately equal to 3.096. Maybe someone interested in approximately answer, so I prepared before video and I plug in this expression in a calculator, and of course you can easily see this approximately answer. Here's your final answer. Maybe you see it on your exam. Okay, right now let's check this answer. Here's our question from the beginning. 3 to the a plus 3 to the a equal to 60. Yeah, so we have 3 to the a plus 3 to the a equal to 60. And right now, let's plug in instead of a, this is our answer, let's plug in instead of a this expression. But I recommend you to write it in a different way. So for proof, let's use this variation. So a equal to 1 plus, instead of log 10 over log 3, we can write it as log a log 10 right here, base of 3. In terms of log property, we can easily use this variation. And for proof, let's use this variation. So instead of a, we're going to plug in this one. Absolutely the same thing as this one, so this is up to you. I prefer for proof, I prefer this expression. But the final answer is both this one, or both this or this. This is up to you. Okay, so let's start with it. So we have 3 to the power a equal to this expression. So 1 plus log 10 base of 3 plus 3 to the power 1 plus log 10 base of 3, and we're gonna equal to 60. Right now, let's simplify this. And a lot of students might be asking, Mr., this is like a complicated expression. We have a log, we have power, so, but let's see what will happen. So in terms of power rule, we can easily split it like 3 to the power 1 times 3 to the power log 3 base of 3. Right here we have 10, and the same thing on the right side. So 3 to the power 1 times 3 to the power log 3, right here we have 10 equal to 60. Okay, and a lot of students may be asking, Mr., this is a complicated expression, so how can we simplify this? But one really important moment, so this trick helps you to simplify this type of question instantly, because this expression 3 to the power log 3 and this one 3 to the power log 3, in terms of log property, this expression equal to 1. Yeah, when we have the same constant right here, and when you have a power, and of course right here you have the same constant. Okay, you need to have log and the same numbers right here and right here. This is equal to 1, this is equal to 1, so you will end up with the 3 times, right here we have only 10, don't forget about it, 3 times 10 plus 3 times 10, 3 times 10, and as a result this one should be equal to 60. Yeah, so we have 3 times 10, we have 30 plus 30 equal to 60. So everything is great. So our root is correct root. You can easily see it. We proved it. So we can write our final answer to our question, and then in the end of the video I'm going to show you a few thoughts how can we find a complex root. So let's do it right now. First of all, I'm gonna write our final answer to this question. So our answer, so our a equal to 1 plus log 10 over log 3, but this is up to you. You can write, instead of this log 10 over log 3, you can write this expression log 10 base of 3. So this is up to you. This is our answer, and a approximately equal to 3.096. This is our real number root. Right now, a few thoughts about a complex root. I'm gonna start right here on the top. So a few thoughts about a complex root. First of all, I'm gonna separate this part, because I'm gonna show you a few thoughts. I'm gonna say a few thoughts about a complex root. Maybe someone interested in this, you can easily see this second part. How can we find a complex root? I'm gonna start with this expression 3 to the a equal to 30. I'm gonna start with this one, 3 to the a equal to 30. So we have 3 to the a equal to 30. And right now, in terms of different variations, in terms of different properties and theorems, first of all, I'm going to start with 3 to the a. So instead of 3 to the a, I'm going to use a natural log. So instead of 3 to the a, I'm going to use this one, e to the power natural log of 3 to the power a, or we can write it as e to the power a natural log 3. So instead of this 3 to the a, I'm going to use this expression. Right now, instead of 30, how can we rewrite 30 in terms of complex numbers? In terms of identity, 30 can be written as 30 times e to the power I to k pi. And we are talking about k from the set of integers. Okay, I hope you understand it. And right now, let's, instead of this 3 to the a, let's plug in this expression. Instead of 30, let's plug in this one. So let's start it from here. So instead of 3 to the a, we're going to plug in this one, e to the power a natural log 3 equal to, instead of 30, let's plug in this one, 30 times e to the power I to k pi. And from here, we need to find our a. We need to find this one. So how can we do this? Of course, with the natural log. So natural log of e to the power a natural log 3, yeah, equal to natural log of 30 times e to the power I to k pi. Right now, right here, natural log a equal to 1, and this power, and in terms of the previous property, we can write it in our right here, not as a power, but in front of this natural log e. But natural log a equal to 1, so we can easily cancel this natural log e. So we have only a natural log 3 equal to, right here, we can easily split it, not like split it, but in terms of property, in terms of the same property, because we have a nature log of a product, yeah? So we can write it as a log, a sum of two logs, in terms of course, nature log in our case. So we have nature log of 30 plus nature log of e to the power I to k pi. Right now, a few thoughts about it, because nature log e equal to 1, and the same thing is right here. So this power I to k pi, we can write right here at this place. So we have a nature log 3 equal to nature log 30 plus I to k pi. Okay, really great. And right now, the final tricky move. Let's divide both sides by nature log 3. We're going to divide both sides by nature log 3. And we have that our a equal to nature log 30. We can write it as nature log 10 plus nature log 3, but this is up to you. You can write it like that. You can split it, nature log 10 plus nature log 3 plus I to k pi. And all over right here, nature log 3. Okay, this is our answer. This is our complex root. Of course, write your thoughts about it. What do you think about this second root? Maybe you have your thoughts, you respond. Of course, write your response in the comments below. If you're talking about real number root, this is our real number root. This is our complex root. This is our approximately answer in terms of real numbers, and this is our full answer to this question. Real number root, complex root, and approximately answer. Here you can see a proof. When we check our root, everything is great. And two variations for proof I used this expression because it's much easier for us to see this property and to solve this question like in 1, 2, 3 lines. And of course you can easily prove it instantly in your head without any problems, because this expression helps you to do this, okay? And yeah, this is our solution. You can easily pause this video. I'm going to move slowly. You can easily see it step by step. Not that hard, but you need to know about log properties and about basic math moves, basic math skills. So what do you think about it? Write your thoughts in the comments below. It's really interesting to exchange information in the comments below, and also it's really interesting to see your response, because a lot of countries, a lot of options, a lot of variants, a lot of ways how can we solve this type of question. And of course, it's really interesting to see it from your perspective. What do you think about it? Write your thoughts. To respond. What do you think about this question? And also it's really interesting to exchange information with different people all over the world. It's really great to see it. So thank you for your time. Take care of yourself and have a great day. See you in the next videos.